get into it. So, we'll down a few more sections to go through. Yeah, so for anyone who is watching online, here's kind of the list of things for the final. There's 20 mandatory questions, 2 bonus questions inside, 22 total. This is the breakdown of those 20 questions for each chapter. Hopefully you found able to spend your time working on them there. So free to take a picture of that. Okay. So go ahead. The lesson here. So as I said, we only have a few more sections left. This is 4 remaining. And the last one really won't briefly discuss. It's not gonna it's not gonna be the final. Want to finish chapter 11. So, okay. 11.8. We're going to start talking about something called power series. So, up to this point in the chapter so far, we've talked about like sequences in the very first, which determining convergence and divergence of those. But then we moved on to series. In general, just like no variables except for n. That would give you each term and determine how those converge or diverge. But now we're going to take an extra step and we're going to take those series and start including variable in it. Specifically, we're going to do what's called these power series, where so they generally form the sum from n equals 0 to infinity of cn x to the n. We have c0 plus c1 times x to the first plus c2 x squared plus c3 x cubed. And then this is going to be equal to some function. We're going to find, we'll probably get back into that more detail tomorrow. But x is a variable, we said, your guide variable, your function, and then these cn's are all coefficients, right? So this cn is going to be very reminiscent, is basically kind of like what we've been working with some so far, except now it's instead of just being that term, it's a term attached to the variable x to some power. So this is just kind of our basic setup for power series, like you said. Essentially, it just, I mean, it's a polynomial, right? Anytime I have a number times just x to a power and I add all those terms up, it's a polynomial, right? And so what this is going to be used for is, you know, it's, can I represent different functions, look at different things just in terms of some sort of polynomial, right? So we're going to be studying that. So this is kind of the basic power series. We also have what's called power series centered at A, which is the more general case where I have some cn term times x minus a to the n power. So instead of it being centered at 0, like that one is, it's going to be centered at A. So the power series kind of moves over, and it might allow me to study a function more at a certain point rather than over here rather than over here, essentially. So there we go. Now, of course, we're not done talking about convergence or divergence yet, but now, since we have some variable introduced here that could change, the question has become a bit more dynamic in terms of not only, you know, do I want to look at that and say, oh, does it converge or diverge? I want to be able to say, what ranges of x, what possible x can I put into this power series here that I have that's going to allow it to converge, okay? And so we have a theorem in this section that talks about this idea of convergence. It says for a given power series, right, that general one at center at A, there are only 3 different possibilities that we can have, okay? The first possibility is that you have the series is just going to converge only when x equals A. Okay, so hopefully that makes sense. If x equals A, what is this term going to end up being? 0. So you get 0 for each term. If I add 0 infinitely to itself, I get 0, right? So that definitely converges. Okay, and there's going to be some series where I have some cn term that makes it so unless the thing is 0, it's too big otherwise, and it just doesn't work. Okay, so that's one case. The second case is going to be that the series converges for all x. Okay, and what this means is that CN term, those coefficients are made in such a way or small enough so that no matter what the A value is, or whatever the X value you put in, it doesn't matter. It's always going to converge because that coefficient is always going to make the term small enough each time and just keep shrinking it. Okay, so that X minus A is powerful enough to change this. So that means for any X, I can plug it in from negative infinity to positive infinity and then it will still work. Okay, now these two cases don't obviously happen all the time. There's going to be an in-between case, which is the one we're going to be talking about mostly, where there's a positive number, which we'll label R, big R, such that the series converges if the absolute value of X minus A is less than R. So if the X value you choose, if you subtract A from it, it's less than that R distance, then it's definitely going to converge, like guaranteed. Okay. And if it's greater than that certain R distance, then it's going to diverge, like certainly, once it passes that number. Okay. Now, you might have a question in terms of what happens if it equals R, and that's more of a, it kind of changes, depends case by case, so we can't really boil it down very well here. We'll of course do examples so we can see what's going to happen. Okay, so with that all the way, let's just start looking at some examples of power series, right? So let's take power series when Cn, that Cn term in each case is going to be equal to 1. Okay, so Cn is 1, and we'll just let A be 0 in this case. Okay, so if I let Cn be 1 for all n and let A be 0, then my power series is simply just going to be x to the n power, right? Cn is 1 and A is 0. Okay, now what is this power series? Is it familiar to us at all? Right, I just have x, which is a variable in this case, or we can think about it just some number I'm plugging in. So we have some number to the n power. What type of series is this? It's a geometric series, right? This is just a geometric series. This is like the most basic geometric series where I don't have some a number on the outside. I just have x to the end. Okay. Now, how do I determine if a geometric series converges or diverges? So yeah, so I have to check R, right? And I'll check the absolute value of R, which is x in this case. That needs to be, if it converges, it needs to be less than 1. Okay, so, and it's going to diverge when the absolute value of R, which again is x, is when does it diverge? Greater than or equal to 1. Good. So what we're going to see is that I'm going to be applying my kind of general tests, to these power series, along with this x, and to be able to say, okay, well, what's gonna happen? What can I say about that x term? So that will converge, right? So as long as that x value is in between -1 and 1, then this thing will converge and it's going to work out just fine, right? Now, of course, not all of them are going to be this simple, right? I can't just have Cn be 1 all the time and A be 0. We're going to get to some more complicated problems, right? And the general way to kind of work these problems out to determine what that radius of convergence is going to be, right? Whether it's if there is a number or whether it's only convergent at 1 or convergent for all x's. We need to, sorry, the easiest way to go about doing this, and if you're not used to doing it now, you'll definitely be used to this section, is by using is by using the ratio test. Or root test. These two tests are going to be very useful to us in this section, and they're going to be just the most straightforward way to make these calculations. Because without knowing what x is, we can't really do as much comparing very easy, and we can't really take limits very easy because we don't know what x is, right? But having this solid ratio test, knowing kind of the range of my number is going to help out a lot, right? So that's really all the discussion I have in this section. Most of our work from this point is going to be just doing examples. So I'm just gonna hop into it. So any questions for me at the moment before we just start doing some examples? Nope. Okay. Good. So let's go ahead and get started here. Okay. So we're going to start with number 4 in this section. Now, all the problems we're going to be doing, and this is your homework problems are all in the same section as well. Ask for this. It says find the radius of convergence which is R. Couldn't say it down here. R is called the radius of convergence. That's what we labeled that R value to be. And what's called the interval of convergence. Of the series. Now, interval of convergence, not quite sure what that might be yet, but I will explain that in due time. We will get to that once we kind of work through the problem. Okay, or start working through it. Okay, so our series in this case is sum from n equals 1 to infinity of -1 to the n times x to the n over the cube root of n. Okay, so I want to determine what the radius of convergence and the interval of convergence is. So I want to figure out how far to the left and to the right I can have x be, like what numbers I can use for x. Okay, so like I said, the easiest way to do this in most cases is I'm going to take this series and I'm going to apply ratio test or root test on it. Most of the time it's going to be ratio test, but you might find the occasional example where root test is pretty easy. Okay, so in order to apply ratio test to this problem, right? So an is going to be whatever's on the inside, right? So we're going to get -1 to the n times x to the n over the cube root of n. Okay, so remind me, for the ratio test, what do I need to do? What do I need to set up? So we need to take the limit, right? And then yes, we're going to take a n and we're going to add 1 to the n, so we get a of n plus 1 over a n. Okay, now whenever I take the absolute value of this thing, let's think about this for a moment. What's going to happen to this -1 to the n part? It's gonna go away essentially. The -1 is gonna become positive, but 1 to the n is just 1. Okay. What about this x to the n, right? We don't really know what x is yet, so it could be negative or positive, right? But if x is at 1, then we probably still need to keep it there. So what's going to happen is that whenever I'm dealing with this absolute value, I'm going to take that absolute value and I'm going to put it over the x, or depending if there's an x minus a in there, I'll do the absolute value of x minus a. So we're gonna have the limit is n approaches infinity, the absolute value of x. Now this is n plus one, so I'm gonna get x to the n plus one over what's gonna be in the denominator. Mhm. And then we divide this by an, or I just multiply by the reciprocal of an, which is going to be the cube root of n over, again, we want to do absolute value of x. Okay, because I don't know if x is positive or negative. Okay. Now, is there any way this is going to, how is this going to simplify for me? What do we think? We have absolute value of x to the n plus one, right? Which, so maybe I'll write out another step for us fast. Since I have n plus one, I can just split up the term and do the same because these powers are adding. So we have absolute value of x to the n times absolute value of x times the cube root of n over the cube root of n plus one times the absolute value of x to the n. Now, these are going to cancel. Those go away. And then I'm going to be left with, so I'll bring it down here. I'm going to get the limit as n approaches infinity. Now, what I'm going to do is I'm going to take that absolute value of x term and I'm just going to set it off to the right side for now. Okay. So, and then I'm going to take that cube root of n over the cube root of n plus one, then multiply that by n. Okay. Now, the limit has nothing to do with x, right? X is just a number in it in this case, right? So if I take the limit as n approaches infinity, that has nothing to do with its absolute value. So all we need to worry about is what's happening here. Okay? What is the limit as n approaches infinity of the cube root of n over the cube root of n plus one? What do we think? It won't go to zero, actually. Right, because it's they're not right to know if it would go to zero. You want to be able to say that somehow the power here is dominating the power here, but they're both to the 1/3 power, right? The only difference is this one has a plus one in it, this one doesn't. So what's the limit going to be? It's 1. So we just get 1 times the absolute value of x, or just the absolute value of x. Okay, so that's our limit. Okay, now. How does this help us? Well, what conditions do we need to have for ratio test to converge? Right? What for that series to converge as a ratio test? It needs to be less than 1. Right? We know it absolutely converges in that case for sure. Okay, so we need absolute value of x to be less than 1. Okay, so if I need absolute value of x to be less than 1, what possible values of x can I have? In that case, x is in between what and what? 0. Well, not just 0 and 1. It's definitely in between 1, but it could also be between -1. Okay. So first thing we want to mention here, or first thing we want to address, right, is the radius of convergence. Now, once you get this limit, right, and you get this, you end up with, where in the limit part you have the absolute value of x, or maybe there's a number there. You need to get the absolute value of the x, or x minus a by itself. And so you just have the absolute value of x minus a is less than something. Okay? Whatever that something is on the right side is going to be my radius of convergence. So in this case, 1 is my radius of convergence. Okay. And we can even see that from here, right? If we're centered at 0, right? Because our series is just x to the n, so we're centered at 0. So I can go about 1 to the right and 1 to the left. and still be converging. So my radius of convergence in this case is 1. Okay? And if I'm greater than 1, of course, it's going to diverge because it would fail the, like it would fail the ratio test. It would give us the divergence increase. Okay? Now, so the radius of convergence is 1 in that case. Any questions for me up to this point? Okay. Now, this interval of convergence. What do we do about that? Well, the reason we want to know about the interval of convergence is because, right, we know that it converges when it's less than 1, and we know that it diverges when it's greater than 1. What happens when the absolute value of x is equal to 1? Well, it still might converge, depending. We just have to check. Okay, so I'm going to work that out over here real fast. Okay, so I'm going to take. So what two values of x would make this equal to 1? 1 and -1. So I'm gonna look at two different series now. I'm gonna look at the series when x equals 1, and I'm gonna look at the series when x equals -1. So when x equals 1, I'm going to get, and again, we're talking about this series here. When x equals 1, what's going to happen to that series? Well, if I plug 1 in there, what's going to happen to the x to the n? Right, so I get -1 to the n times 1 to the n over the cube root of n. What's 1 to the n power? 1. So I just get sum from n equals 1 to infinity of -1 to the n over the cube root of n. Okay, so now the question is for me is, does that converge or diverge? Right? If I wanted to know if it converges or diverges, what do I have to test? Or what test should I use? Maybe. Yeah, I want to use alternating series test, right? So I'll just go ahead and use this space because this one's going to take a lot less time. Right? We need to pass two conditions. The first condition is that the limit is then approaching infinity of what? What are we taking the limit of for AST? Is that 0? Good. And then we also need to show that 1 over the cube root of n plus 1 is less than 1 over the cube root of n for all n. Or, I mean, we can just look at it. Is that true? Yeah, n plus 1 is bigger, right? So that means the whole denominator is smaller. Okay, so what does that mean for the series here? Does it converge or diverge? Converges. So I'll put a. Okay, so that one converges. Now, if I put x as -1 inside, I'm going to get -1 to the n, so the sum. So that's just from being there, but I'm also going to get another -1 to the n, right? Because now we're putting in -1 over the cube root of n. Okay. So I have -1 to the n times -1 to the n. Any guesses on what's going to happen?
Do the negatives cancel each other?
Mm-hmm. Yep. Yeah, the negatives are going to cancel because you can either just think about it, oh, well, you know, they're both of the first power. You get -1, -1. It's going to be 1, or you can keep going. Or you can just add, you know, n plus n will give you 2n, right? So I get -1 to the 2n. But -1 squared is 1. So you always get 1 up here. So this is the same thing as sum from n equals 1 to infinity of 1 over the cube root of n. So, what do we think? Does that series converge or diverge? Why do you say that? It does diverge, but why? By p series, yeah, just by p series. Yep, because p, so p in this case is 1/3. It's less than 1, right? Less than or equal to 1, I guess, so this means it's divergent. Okay. Good, so it still converges when it's -1, but it diverges when it's 1. So I'm gonna write the final answer for everything over here. Okay, so for sum from n equals 1 to infinity of -1 to the n, x to the n, over the cube root of n. Okay, we're gonna have our radius of convergence being 1. And then we have an interval of convergence, all right, IOC. Right, which is this interval. So we have -1 and 1, but then we had to go through decide if we included both of those or not, or if we included which ones we could include, which ones we couldn't include, that would make converge though, right? We plugged in 1 and said, yes, it does, right? So we are going to put a bracket around the 1 to include it inside the interval, right? Because it still makes it converge. But when we put the -1 in, it diverges, so we cannot include that. So this is our interval of convergence. Okay, so all in all, what have we found? Well, we have found that this series has a radius convergence that's 1, and it converges. It can converge. It had center at 0, of course, and then it converges when it's equal to 1, but not when it's equal to -1. But it's convergent when for every other convergence. Okay. Questions for me on this? Yes.
What is that absolute value of x equals absolute value of x equals 1? How did you get that far?
Well, this is, so I took the limit of this whole thing, right? But the absolute value of x was unaffected by that limit, and we took the limit of this piece, which is 1, right? So we end up getting 1 times the absolute value of x, right? And then ratio test, right? Remember, ratio test says that for the series to converge, it has to be less than 1. So that's where that less than 1 came from, right? Because I wanted to converge.
What's next to it?
I'm just saying, to say the absolute value of x is less than 1, I'm saying that -1 is less than x. So those are kind of equivalent statements there. But this one helps us to form our interval. Any other questions for me? We'll do another example, of course, but. Nope. Okay, let's do. Let's see. Let's try something. Let's do review real fast. Be a good one. Okay, for number 8. It's asking the same thing. Same conditions. Okay, so we're finding the radius of convergence and the interval of convergence. But now we're dealing with the sum from n equals 1 to infinity of n to the n times x to the n. Okay, so I need to determine if this is what the radius and the interval of convergence is going to be for this thing. So let's do it. Okay. So I have n to the n and I have x to the n power, right? What test might be more valuable here? Yeah, we want to use the root test, right? So I'm going to take the limit as n approaches infinity of the inverse of the absolute value of an, which will be the limit as n approaches infinity of the nth root of, and we have n to the n again, we need to do absolute value of x. Okay. So what am I going to get when I take the nth root? Yep. Okay. So what is my limit? Again, x is just some number at this point. Okay. What happens when I take the limits in first infinity of n? It's infinity. Uh-oh. That's definitely greater than 1, right? For sure. So this almost diverges everywhere. Almost. Except for one value where it converges. So what value do you think it's going to converge at? We wouldn't want to use 1/n in that case. X is just a number. We don't want to find out the thing on the inside. We want X to be 0. Those converge, right? The series converges only when X equals A, right? Otherwise, if it's any other number, it's going to diverge, right? So we do not, right? I can't plug in anything except X equals 0, right? So what do you think the radius of convergence is going to be in this case? Right, if I can only use one number, I can't go anywhere besides that one number. Right, it's just at one point, the radius is going to be 0 though, right? Means I just can't go out any further than that point, right? And then the interval of convergence is, yeah, it's just gonna be a single point, which is 0. Okay. Yep. Makes sense? If this was, I'm just gonna do it just for the sake of time, but. If it said we had, x to the n over n to the n, we would actually get drastically different results, because I would probably use a root test on the skin, right? So I'm gonna get the limit is n to infinity of x to the n over n to the n, okay, and then we can take the value, so we're gonna get the limit as it approaches infinity of the absolute value of x over n. What is that limit going to be? It's 0, because I just have some number over n, so I get 0, which that's definitely always less than 1, right? Okay, good. So that means for any x, the series is always going to be convergent. So what would the radius be in that case? Infinity, yep. What would the interval of convergence be in that case? Don't need to worry about testing either side. We can't really put, not like we can put brackets around infinity or infinity anyway. But that would be it. Okay, so just like this was a problem, and this one converges everywhere. So, questions for me at all on this? Okay. So we have time for at least one more example. Let's try one that has something besides just x to the n. Let's do probably number 16. So for 16, we're going to have, again, same instructions. As I said, all the problems in this section have the same instructions. You just do the same thing over and over. We're doing sum from n equals 1 to infinity of -1 to the n over two n minus one times two to the n times x minus one to the n power. Okay. So I have this power series that's centered at what number? One, right? It's whatever x minus number is. If it was x plus one, then it'd be negative one. We have a power series centered at one in this case, but I'm gonna just do the same exact process, right? Who wants to try to do root on this problem? Probably not. We can probably try to do ratio still in this case. So let's try ratio. Okay. Most of these are gonna be ratio. But you feel like you do ratio first until. So we're gonna do ratio test. We're gonna take the limit and then approach to infinity of the absolute value of an plus one over an. Okay, the negative one to the n is gonna go away again, and then every time I write x minus one to the n or n plus one, I have an absolute value around it. Okay, so I'm gonna have the absolute value of x minus one to the n plus one over two. Okay, now I did see this in some people's homework, so make sure you're plugging in correctly. This is gonna be two times n plus one minus one times two to the n plus one times two n minus one times two to the n over absolute value of x minus one to the n power. Okay, now, again, I wanna highlight this. You put n plus one in here, and that two has to distribute to each term. So I get two times n, two times two, two times one, so I get two n plus two minus one, which gives me two n plus one here, right? If you were to just say, oh, multiply two by the n and not by the one, you get two n. That's incorrect. Okay, so just be careful. Okay, is there anything that's going to cancel here? Is there anything that's going to cancel here? Yeah, so this is the same thing as the absolute value of x minus one to the n times absolute value of x minus one, and then we could even rewrite this two to the n plus one is two to the n times two. Okay. Anything going to cancel? Yeah, so we get x minus one to the n canceled out, and then two to the n cancels, and then that's it for now. So we're gonna have the limit and then approach to infinity, and so we're gonna have the absolute value of x minus one times two n minus one over two n plus one times two. Okay. Good. From here, I'm just gonna take this x minus one and the two and just kind of set them off to the side, and we're gonna focus on that two n minus one over two n plus one. Okay. So the limit of this part is just what it is, but what is the limit of this piece going to be? It's gonna be one, because they have the same degree, so you just take two divided by two, so you just get one. So this ends up being, so this limit is gonna end up equaling the absolute value of x minus one. Good. Now, I want this to be less than what? One. I guess less than or equal to technically, but we know it converges for sure when it's less than, okay? But like I said, we need to solve for, we need to get the absolute value of x minus a by itself, right? So I don't want this two to be here. So what should I do with that two? Yeah, multiply it. So what am I gonna get? So we get absolute value of x minus one is less than two. So this right here is my radius of convergence. Okay, two is my radius now, not just one. Okay. Now. Be careful here, alright? We are saying, so my radius convergence is 2, and that's for x minus 1. So what this says is that -2 is less than x minus 1, which is less than 2. Right? So so I want to solve this for x now, because I need to see what the x values are that I'm looking at. So how do I solve it for x? So we get -1 is less than x, which is less than 3. Okay, good. Now, these two numbers are the two numbers that I need to plug in and see what's gonna happen. Okay, so let's go ahead and do that. I'll make some quick room over here on the side of the board. We're gonna test -1 and we're gonna test 3. So if I take -1 and I plug it in, right? What is my series gonna be? We're gonna get sum from n equals 1 to infinity of -1 to the n over 2n minus 1 times 2 to the n. And then multiply that by. So if I put -1 in there, what am I gonna get? I think someone said -2 to the n. Okay, now just like the other problem, right? This negative and this negative here are going to cancel each other. And then I also have that also will give me 2 to the n over 2 to the n. So this is the same thing as n equals 1 to infinity of 1 over 2n minus 1. Okay, again, this negative and this negative will cancel each other since they're the same power, or even if they weren't, they would still cancel some way. And then, or maybe come out. And then 2 to the n over 2 to the n will cancel out, so I'm left with this. Okay. Is this series convergent or divergent? What do we think? How would I test if it's, how would I test it? What would be the easiest way? Well, if we do divergence test, I just get 0. That doesn't tell me anything. So we don't want to use that one. It's the next option here. Good. This is greater than 1 over 2a. Right? Now this is, I can just take this half and pull it outside, so this is just the harmonic series. Right? Half of the harmonic series. Right? But we know that this one diverges by p series. So since this one's greater, right, it's greater because subtracting the 1 will make it a smaller denominator. That means that this one is also divergent by comparison test. Right? Does that make sense? So I cannot include -1. Now, let's see if we can include 1. When I include 1, I'm going to get the sum from n equals 1 to infinity of -1 to the n times, or sorry, not 1, we're plugging in 3. Okay, so we're going to get times 3. What am I going to get when I plug 3 in here into my series?
You get it, times 2 to the n, that cancels out.
Good. So we get positive 2 to the n, which is still going to cancel out. So we're going to get the sum from n equals 1 to infinity of -1 to the n over 2n minus 1. Okay. How do I determine convergence here? Yeah, AST. Okay. So condition 1 is the limit. Does the limit go to 0?
Yeah.
Good. Is 1 over 2n, which should end up being 2n plus 1. If I put n plus 1 in there, is that less than 1 over 2n minus 1? Good. Yep, they both pass. So what does that mean? Convergent by AST. Okay, So it converges when x is 3, and it diverges when x is -1. So in the end, my final answer should be that the radius is 2, and my interval of convergence is going to be -1, not including -1, 3, and then I include 3. Because 3 works, but -1 not. Okay. Any questions for me? We'll be in top here. I think that's good. That's all it is, just doing a lot of that. Very close to the end of our lesson here, so. Yeah. I think that's a great your day. I do need to get out here, but I'm happy to. Thanks for your attention real quick. If you have anything for me. Yeah. For what?
Like you give a head design and
Well, like,